Presentation to go for our special session later on this afternoon. And I'm very happy to introduce to you my colleague, in fact, assistant professor at JADS, Giuseppe Cascavilla, and he will take us on a journey in cyber threat analytics, also using a couple of demos just to spice this up just before our session. So, Giuseppe,
thanks. Hi everyone. I'm Giuseppe Cascavilla, as Julian said, assistant professor at JADS, and my main activity is cyber threat intelligence, cyber security, and basically I'm looking for trying to fight cyber crime in surface, deep and dark web. Any of you is familiar with the dark web, drugs, whatever? There is some. At least anyone is familiar with the dark web? Have you ever been there? No? No? Okay. Okay then. We are trying to go in there together, and I will try to explain also how we employ large language models in this specific context, okay? So we will see an introduction of the www. I don't think it's something new for you. I will go through the surface, deep and dark web. I will talk about how deep is this dark web, this fancy place, this dark space. We will see the dark economy and the money that are connected to this type of criminal activities. We'll see what's in there, because I don't know if you've never been there, probably you don't know exactly what there is there. And then I will present you Kratos and Sensei, our approaches to try to fight this type of crime, okay? And then the state of the art. So what is the www? The www is the web pages, pictures, videos, and the online content. Basically, the World Wide Web is rather than an online network based on HTML pages, okay? And differently, the internet is the actual network of networks where we have all the information. Then where we have systems like Telnet, FTP, the internet game, the email, all of this stuff. It's basically in there. This is just in order to provide a little difference between these two parts of the same web. Okay. This is an idea of the internet map. This is the QA. Actually, there is no JADS in there because it's too small. But just in order to give you an idea on how big is the surface web and where is actually the university where I belong. So this is just a nice GIF. Okay. So this is an idea of the internet, and this is more or less the internet map. Okay. This is the internet division. Okay, we can say that we have the surface web, that it's basically it represents all the stuff that we are doing, that we are using daily. Okay, we have Skype, we have Facebook, we have all the applications that are using every day. Okay, and then we have the dark web. Okay, you have here basically two of the biggest network. There is Tor and there is I2P. Both of them are dark nets. Okay, it's just a subset of our network, and you can use these different tools, but they are not the only tool. There are other tools. Okay, to access different type of darknets. Okay? Just to give you a better idea on with your position, we might say that the surface web is the good, so where there are PhDs teaching assistants, maybe students when there is you, and the dark web is the bad part of the web, where there are your supervisor, the postdocs that are threatening you, the assistant professor like me, the associate professor, and stuff like that. So this is just to give you an idea of the internet division. Okay, but we will go through that. I will explain. But basically, is how big the network are, the surface web and the deep dark web. But I will give you details.
How do you measure size?
There are some studies that have been trying to measure these numbers. Yeah. But they are pretty old. They're extremely old. But I will discuss also about this. So, as I was saying, the good, the bad, and the ugly. I don't know if you know the movie, but the good, I used to target the surface web as the good part of the web is the part of the web that, as I said, you used to access in your daily activity. Okay. Then there is the bad. The bad is the deep web. Is a subset of the web that is not indexed. Okay. So all the stuff that it's in there, basically, it's impossible to find using Google Chrome or Edge or whatever, okay? As it is written here, the majority, this is not really a criminal, let's say, part of the web, even if we can discuss about that. But here, the majority of the deep web is made by databases, records, medical records, and this type of stuff. This data that companies don't want to show outside. Okay, so basically this is there are also newspaper and information that are censored maybe in those countries where it's complicated to access newspaper. This is more or less the deep web. And then there is the ugly, the dark web, is the less accessible subset of the deep web, because you need to use specific tools in order to access this part of the web. As I was saying, two of the most common tools are Tor and I2P. There are malicious actors in the dark web. Basically, that's pretty common, because the dark web and Tor, for example, they have this capability of improving your privacy. Okay, so basically, Tor works providing 3 different relays. I don't know if you know how it works, but basically Tor provides you 3 different hopes. Okay, and it works like a proxy. Okay, so basically your identity is completely hidden, and you can even modify the code of Tor if you would like to put more relays between you and the actual dark web that you would like to visit. Okay. Here we have, of course, drugs, illegal weapons, malware, stolen data. It is basically whatever you want. The point is, how big is the darknet? Okay. There are a lot of papers, newspapers that are talking about this stuff. That the dark web is extremely big. It's 500 times than the normal web. I mean, there are a lot of articles regarding the size of the dark web. Actually, the size of the dark web is just 0.006% of the number of the real websites. But we say that it's really complicated to measure the dark web due to the nature of the dark web, because basically there are web markets or HTML pages that are appearing and disappearing in a couple of hours. Okay, so it's complicated to measure the dark web, but I mean, some papers from 2019, and here there is also the reference if you want. That's why I was saying that it's really old, this machine, because it's complicated to have an actual picture of this dark web. Only around 8,000 onion domains had a live site, and only the 50% of domain was found in there. Okay, so basically this is the size of the dark web. And what about the deep web? The deep web is actually the biggest part of the web. Because actually, if you consider that in there are all the data, it's used basically as a storage, here we can say that the deep web is the biggest part of the web, and I mean, there are studies that are saying that it's basically between 400 and 500 times greater than the surface web. But of course, here we are talking about data, okay, amount of data. That's the actual estimation. And the deep web hosts approximately 7,500 terabytes of data compared to approximately 19 terabytes hosted on the surface web. Okay. What the dark web looks like. This is actually a picture. It's taken from the previous papers, and each dot basically it's an onion domain, and you can see the aggregation of multiple dots together. Okay, are basically marketplaces. Okay. Here there are also two most popular marketplaces. I don't know how old, but should be also from 2019. This is also another idea of the size of the Tor network. Okay, so basically here you have the clear web, and the Tor network is compared basically to one single dot. So you can see how small this part of the web is. Okay, I know it's I'm talking probably too much, but I will tell you just to calm down because we are going to the point. Okay, so just to give you an idea of the economy of the dark web. This is, for example, a study from 2016. I couldn't find anything more recent. It's also in this case, it's particularly complicated, difficult to measure the amount of money that are going around the dark economy. Okay? Also because they are not using simple euros or dollars. They are using mainly bitcoins, and it's complicated to track down the bitcoins because there are mixers, and the mixers are just improving the actual complexity of following these bitcoins transactions. But you can see that illegal drugs are basically the biggest part of this dark economy, but we have also non-drugs activity like fake money, e-books, credit cards, fake IDs, okay? And we have also prescriptions. I mean, we have the oxycodone, the Valium and the Xanax, opioids that are basically apparently, looking at the latest news, are now available also in Europe. It's not a case of US anymore. So we have apparently opioids also here, and it's also in this case it's complicated to track these opioids down. But this is just to give you an idea on how much money are involved in this illegal transaction, illegal activities. Here and there I have been able to retrieve some information on a more recent stuff. Okay, for example, in 2021, dark markets made 2.1 billion in cryptocurrency. Okay, so it's really a lot of money, and most of them are, of course, generated from drug sales. Okay, Hydra, that has been seized, was one of the largest marketplace with this revenue in 2020-21, and alone was generating almost 80% of the total dark web revenue. We see an increase of these illegal activities and illegal transactions in the dark web. Consider that in 2016 the average drug transaction on the dark web drug site was $160, rising to $490. We are always talking about cryptocurrency. Okay. Direct buy and sell a drug transaction increased in 2021. Even if now consider that if you are going to buy anything in the dark web, we are not directly talking with the vendor. Okay, there is always the marketplace in the middle that is offering you this service. Okay, what does it mean? It means that you give the money to the marketplace in order to buy items. The marketplace used to keep this money until you do not receive the items that you were buying. Okay? Once you receive the items that you bought online, the marketplace leave the money to the vendor. Hence, you can understand that it's even more complicated to track down these bitcoins, because each time the marketplace generates a new wallet. Okay, it's just random wallets that are generated randomly. The darknet drug market was worth 27 million in 2022. Okay, so it's quite a lot of money. This is some price list. This is directly taken from the dark web. It's not complete because there are a lot of different items. You can find all of them in here. There is the Prime Index in 2022, so it's really recent. But just to give you an idea, social media account can go between $60 and $2. Okay, forged documents, fake documents. Here it depends on which type of passport you are looking for. For example, for the European passport, like the Italian one, or the French one, or the German one, they are really complicated to forge and they are more expensive, usually. Credit cards, here there are stolen credit cards that you can buy for around $100, but also $20, whatever. But there is malware, okay? The malware is sold based on the quality. So you can buy the malware, it's just, let's say, plug and play. You can run the malware and you can start your phishing campaign or whatever you want, okay? And of course you pay the malware based on the quality and the success rate, of course. Money, data and violence. This is more or less what you have in the dark web, okay? Silk Road was another biggest marketplace. Consider that the FBI is the second largest owner of bitcoins. This is due to the fact that when you are seizing the marketplace, when the FBI used to close marketplace, they take the money. Okay? So that's the reason why the FBI is the second largest owner of bitcoins. There are information. Basically, there are information of everyone in the dark web. 620 million accounts was available for sale in the dark web, and probably even more nowadays. But there is not only money, you can also decide to hire an hitman if you want. Talking with police officers, I don't know, I cannot tell you exactly if this is real, because also some police officers were monitoring this stuff and they actually don't know if it is a scam or if it is really possible to hire people, but there are these services basically. There is human trafficking, of course. We have been working also with some other projects at JADS on these human trafficking marketplaces. Mainly now they are working with chat, okay, these private chat activities. Maybe the most known are Telegram and Signal, but they are in place specific chat that are really taking care of your privacy, where you can discuss about this human trafficking. There are the red rooms. I don't know if you know the red rooms, but basically it's a service where you can see people, where you can see violence, of course, and people getting abused. Okay, so you can buy this service, and you can watch this movie. There is, of course, a lot of child pornography. This image that you see here, it's an image from Terde Home. A few years ago, I think in 2000, 2010, I do not remember exactly the date, but they built this digital baby, okay, in order to hook the people that were using child pornography, and they have been able to arrest a lot of criminals that were looking for this child pornography. And then, of course, we have terrorist organization, where you can decide to send money in order to help this organization, or in order to recruit other people. Okay? So this is more or less what we have in the dark web. Okay. So here it comes our idea. We decided to build our proof of concept approach. It's actually a pipeline that is currently working. It's in place. We decided to start crawling this data. Crawling this data, scrape this data, and try to build analysis of this specific data. So here it comes Creator. It has been published just a week ago in SummerSOC 2024. And how Creator works, it's a web crawler that is browsing the web. This is the explanation of the crawler. What is the crawler? It's basically a web spidering. So in order to try to index all the pages that are online, we are applying this same technique to the dark web. It's not that easy as it might look like. This is the strategy. So basically the pages are working like nodes, and the hyperlinks are working as edges in order to connect different pages. It works exactly like that also in the dark web. What is the point? The point is that the dark web is really privacy preserving. Okay, they don't want you to crawl this data. There are bots in place, there are robots in place in order to check if you are crawling information, and they used to cut this activity. You can do the same also on Facebook. For example, if you start crawling information on Facebook, Facebook recognizes that you are crawling information, and Facebook cuts the connection. Okay, and usually they also kick you off from Facebook, banning the account. You can do it. It's the same also on Instagram, and I think it's now the same also on Twitter. Okay, so here it's even more complicated. There are also captchas. I don't know if you ever seen any captcha from the dark web, but they are extremely complicated to solve. Okay, it's we are now trying to work on some image recognition in order to try to automatically solve these captchas. Of course, if you start doing excessive requests, you will be recognized as a DDoS attack, okay? And hence you will be banned again. The captchas that I was saying, I mean, it's really complicated. The dark web is really protecting its information, okay? This is more or less the architecture, okay, that we built. We have the curl module with the URL queue. It's a multi-thread approach, of course, and all the pages are stored locally. Are stored locally in order to be then processed and extracted, in order to extract all the information. Okay, we use a random user agent in order to bypass some Tor bots. Okay, do you know how a random user agent works? Okay, let's say that I'm opening multiple accounts on the same website. Okay, opening multiple accounts, I can retrieve multiple cookies. Okay, so what does it mean? It means that if I have 10 accounts, I will have 10 open activities. Okay, 10 cookies. I use these 10 cookies in my crawler, and I used to make the request using each time a different cookie, so that the marketplace will recognize me each time as a different user, because the cookie is connected to the session of the user, of course. Okay, it's the open session of the user. This one was our approach in order to bypass the robot of the marketplace, in order to avoid to be recognized as a DDoS attack. Okay, let's. This is the marketplace that I would like to grow. It's a French marketplace, it's online. Let's see if it works. This is our tool, of course. There are some log, of course, log activities. Here I was setting up my YAML. There is the website that I would like to code, and here there is the folder. Let's see if we are going to receive pages. Yes, we are going to receive pages. These are the HTMLs that I'm receiving. I'm currently crawling this website, and here the tool is currently working. Okay, so we can stop it now. Okay, so let's open these pages. Now, here we have the HTML page with all the information. Of course, in order to make the crawler, let's say, lighter, we are not crawling images, okay? But if we want, we can crawl also the images. But it might take more time. What do we have here? Here we have the HTML, okay? And there are a lot of information that we can actually use. We can actually use as we want. We can apply large language models in order to retrieve information. We can simply use regex in order to extract textual information. But in our specific case, we employed a scraper, okay? Just to connect on the previous talk, in order to scrape this data, at the beginning we were manually doing that. When I'm saying manually doing, means that we were building the scraper using the HTML tags. Okay. The problem is that each marketplace has different HTML tags. So you can imagine that if we have 10 marketplaces, we had in place 10 different screen. Okay, that was too much time consuming. That's the reason why we decided to employ large language models. Okay? And for this specific case, we decided to use Kleiner. It's a model that we found on archive. I don't know if it has been published yet, but it's a main entity recognition approach. Okay, consider that without training the model, we were able to reach kind of 60% accuracy. So it was really good. After training the model, we reached the 80% accuracy, more or less. When I'm talking about accuracy, I'm talking about the ability of our scraper of recognizing, for example, who is the vendor, the seller in this specific case, what is the rating, what type of drugs. So my point is that I would like to tell to my large language model, give me the drug, give me the vendor, give me the type of stars to every different marketplace. We are going to submit this work with the NFI, the Netherlands Forensics Institute. They were involved. I don't know if you know the Netherlands Forensics Institute, but it's a governmental office that is working on this type of criminal activities, and we are going to submit the paper that it's already prepared. Okay. Then we have the scraping activity. Okay. Just coming back to this one. Just to explain what is data scraper. Here it's an example. We have an Amazon HTML page, and I would like to retrieve the title, the rating, the price, the ship from, and the ship to. That might be even drugs. Okay, it's basically the same. The point is that I would like to have this approach for every different marketplace. So the model has to be needs to be unconnected to the marketplace. Okay, so it has to work with every different marketplace in order to extract automatically this information. This is, for example, an example. This is, for instance, an example of what we were doing manually. So you have actually the actual classes, okay, and we were looking for these specific classes in order to extract information. We use this code also to train our large language model. Okay, so the point is that we used 2 or probably 3 marketplaces, and the model was able to recognize every different type of marketplace, only using the tags and the type of stuff that we would like to retrieve. Let's see some tools in action. I showed you the crawler actually. I would like now to let you understand what does it means retrieving data from the dark web. This is a platform that we developed with under the project Anita, and the actual graphical user interface has been developed in conjunction with law enforcement. So we did some work together in order to understand where to place stuff and how to place stuff. So here you start with some specific analysis on different places, but I can go a bit further so we can see, for example. Here, for example, trend analysis related to cannabinoids, opioids, and whatever. But we can also go through simple single marketplaces. Okay, for example, here is a dark marketplace, and here we have the countries. Yeah. So here it's in order to understand what type of drugs are in which type of country. Okay, it's just some analysis. We can also do a comparison activity between different countries. If you would like to understand the differences in using drugs among different countries, okay, we can go through this one, for example. We can go. So, for example, here we have in Netherlands a lot of cannabinoids, okay, and stimulants. Okay, this is basically what we have here compared to the Australia that see a lot of opioids as well and psychedelics and stuff like that. Okay, this is in order to compare the activities, different activities among different countries. So then we have the GMAP in order to go a little bit deeper into each vendor. Let's go for Agatha. Okay, here you have, for example, Evil Genius that has number of products 48, and here are the different type of products that this guy is selling. There is also Amazon, of course. We have Seed Everyone. Let's see if we find anything here. They are mainly working with cannabinoids. Okay, so you can see PhD work. They are mainly working with cannabinoids. The layers tasks also do have some textual stuff. So basically, just in order to copy paste information that will be more complicated to copy paste from HTML. And then we are going also to build an actual network representation of these two marketplaces, in our case Agartha and Amazon. And we see that Maurelius is a guy that is selling drugs on both these marketplaces. Okay? All of these are, of course, all the people that are in there. Okay? Made in France and so this is actually how we are employing some technologies and some large language models in order to retrieve information and build analysis. We are not the only one. I mean, of course, there is, as I was saying, there is Steph the Home that is actively working in child pornography. We have been working in the project Anita. Protect, we use this same stuff in the context of protecting cyber physical spaces. In this case, we were actually testing hardware in public spaces. For example, we tested hardware in Malaga, we tested hardware also in the eastern of Europe in order to fight terrorist attacks. Okay, that was the idea. But there is also Magneto, that is another project that is now closed, of course. And yeah, this is more or less it for my slide. If you have any questions.
So any questions, remarks, findings, worries? Yes. Still have time.
So, what about identity theft? It's a completely different subject.
The identity theft, it's a completely different subject, but at least in this way, I mean, the point is that we don't try to go into the details, okay? For example, malware activity, identity theft, or specific drugs. The idea talking with the layers that they would, I mean, right now there is only one biggest partner that is doing this stuff, it's Palantir. The problem is that Palantir is selling their license for millions of dollars, and the layers cannot always afford this type of stuff. So that's the reason why having a threat intelligent platform that is able to provide you as a layer information. Okay, so that's the scope of this project. We are not looking for criminals. We don't want to catch criminals. We would like just to provide you information. Then it will be you, together with other analysis, maybe in place, following people, tracking IP addresses or whatever, to have a more clear idea of what that's.
More questions? Otherwise, I guess we can discuss that during our special sessions later on. So, thank you again.
Thanks.